Okay, right. So benzene nitration only we have to do today. Benzene nitration, right. So the basic reaction, all right. Conc HNO3, conc H2SO4, 50 degrees Celsius temperature you need in order to make this reaction happen. So the product will be benzene attached by NO2, and then water will come as a byproduct, right? Water will come as a byproduct. Water name, sorry. ඒකට H2SO4 කියලා එන්නේ. ඔව් water තමයි byproduct එක. අර H2SO4 මෙතනින් දාන H2SO4 ආයි මෙතනින් එනවා. It acts as a catalyst actually. හරි water එනවා. water ටික දාමුකෝ. And H2SO4 acts as a catalyst here. So the reaction is happening in between HNO3 and H2SO4 acts as a catalyst here. So if they ask in a question, you have to write like H2SO4 acts as a catalyst in this reaction. Let me tell you why is it acting as a catalyst and how is it happening. In the mechanism, we will understand that. So there are two steps. I told you in every benzene's mechanism, there is the formation of the electrophile, right? Formation of electrophile is there. So this first one is the formation of electrophile. So H2SO4 molecule, we can enlarge and write it. Like this, okay? And there is the HNO3 molecule. I hope you know how to write the Lewis structure of HNO3. Like this, okay? Right. Now what happens is there is a charge separation in between the oxygen and the hydrogen, right? Oxygen and the hydrogen, there's a charge separation. So arrows we draw in red color, as we told in the previous class. Now what happens is this oxygen will attack this hydrogen. This oxygen will attack this hydrogen, and hydrogen is like, I don't want your electrons, so keep your electrons. අර කලින් වගේ reaction එකක් තමයි වෙන්නේ. හරිද? Now let me draw this to the left a little bit. Right, that works. So now what happens is a molecule like this will form. Then with oxygen එක ගහනවනේ hydrogen, it will attack, and then what happens is it will attach. Every time it attack, it will attach. So this oxygen will attach to that hydrogen, and it will form a very unstable compound with oxygen positive charge. And the remaining part, this H2SO4, the remaining part, it will form HSO4 minus. HSO4 minus. Sorry? HSO4 minus. Now, since this is unstable, what happens is the bond will get removed. It will get chased away and the bond will get removed. And now what happens is it will form H2O. This part will form H2O. This part I mean, okay? It will form H2O. And NO2 plus and HSO4 minus. So this is the first step of the mechanism. This is the first step of the mechanism. So here, this one is the electrophile. So formation of the electrophile is the first step of the mechanism, right? First step of the mechanism. Then the second step is attaching with the benzene. Attaching with the benzene. So there is benzene, poor benzene here around. NO2 plus is roaming around, right? And now what happens is the benzene will attack the NO2 and it will form a bond with it. Like this, okay, like this. And then what happens is resonance will happen. Resonance, I told you, if they ask only, you have to draw it. So let me draw here. මම මෙතන අඳින්නම් ඒක. So if they ask, you can draw it. Otherwise, you don't need to draw. You can just directly write it. Okay, right. So these are the resonance structures that will undergo. Farmer Muslim, what was that word? All, I can't read that word. What was that? Are you using a Nokia phone or something like a button phone? What is that word? I can't see. Allocate. මෙහෙමයි. Like, according to the class which I went last year, and my school teacher, she was like, if they asked, you can write it. If they asked, you can write this part. But if you are like, you're not like, are about suspicious. Now, if you're suspicious about it, like, what if I write, there's like no issue if I write. So then write it. What I'm telling is like, if you can trust the word, then you can avoid writing this. Or else, if you like really want, then you can write this. Then no issues. If you didn't write or not write, it will take only like maybe maximum 50 seconds. Maximum 50 seconds to write this. You can spend that time and write this if you want. It's only one mechanism in the paper and they won't ask you to draw 100 mechanisms. So one mechanism, you can just draw this and finish it. Right. Then the next one, this is the third step actually, the resonance undergoing. And then next one, what will happen is, I'll draw the hydrogen to this side. Right. Now, the HSO4 minus, who is like looking from the side, will attack this hydrogen, arrows with red, will attack this hydrogen, and what will happen is bond will get removed. And now this one will form the NO2 molecule and H2SO4. So H2SO4 is there at last, H2SO4 there is at the beginning here. This is H2SO4. So H2SO4 acts as a catalyst in this reaction. H2SO4 acts as a catalyst in this reaction. Write this down quickly. When you are finished writing, please let me know. Okay, then shall we go to the next one? Scroll up here. Okay. Now the complex part, like a lot of you are having problems with this mechanism. Mechanism make a name, like the kinetic side of this. This alkyl halide with KOH, alkyl halide with KOH, this reaction, very important. This is the next mechanism. Now benzene, we talked about all the benzene mechanisms and finished it. Now we are moving into the alkyl halides. Alkyl halide with KOH. And this one is of primary. This one is of primary alkyl halides. Primary alkyl halides. Right? This is for primary alkyl halides. So a lot of you are like, "Ara ahila tiyawada me bimolecular nucleophilic substitution and like unimolecular nucleophilic substitution." Likewise, you have heard that, ne? Right? I also had that issue back then when I was doing A levels. I clarified that on my own. So what is this? So this is for primary alkyl halide. So primary alkyl halide, I'll write the reaction itself. CH3, CH2, Br. So this is an alkyl halide. A halide atom is attached. Sorry. So KOH, aqueous, right? Aqueous KOH, okay? It's not alcoholic KOH. Alcoholic KOH will form what? The alkene. දැන් මං ඉන්නව class students මගේ ළමයින්ට මං කියලා තියෙන්නේ මෙහෙම scene එකක්. හරිද? දැන් හිතන්නකෝ CH3CH. I don't know whether you will like this or not. I'll tell just. හරිද? To distinguish in between alcoholic and aqueous, what are the products and how to predict the products in a fun way. මං කියලා තියෙන්නේ මෙහෙම එකක්. හරිද? Now, if it is alcoholic, now people, when a person is drunk, what will happen? He can't walk straightly, right? Now OH minus is drunk now. Why? It's like alcoholic. It's alcoholic. Now what happens is this alcoholic OH minus, he can't walk properly. So he'll like go like this, level like this, like this, and hit another person's door. It will hit another person's door. Now what will happen is that person will start to react and then like it will form a double bond here and then this one will get removed. And that's the formation of an alkene. That's the formation of an alkene. Now imagine like this is aqueous. This is not alcoholic. Now he knows where to go. He will directly go to his home and then the Br will get removed. I don't know whether BR if it's unknown or not. I don't know that. So however, he will go to his location directly. If it is alcoholic, he can't go. හරිද? දන්නවනේ scene එක. මෙහෙම ගියා. ගැහුවා. හරි whatever. මේක ගහන්න පුළුවන්. හරිද? මේකට ගහමුකෝ. Right? Something like this. So that is how you distinguish in between products. Okay. So the product will be CH3, CH2, OH. Aqueous KOH. However, minor product can be formed, okay? A minor product. Again, අරකට වෙන්න පුළුවන් ද හදිස්සිය මොකක් හරි නිකන් දන්නේ නැද්ද ඩාම් වෙනවා ඩූම් වෙනවා කියලා ඉතින් අනිත් ගෙදරට ගහන්නත් පුළුවන් ඒකල ඇල්කීන් එකක් හදන්නත් පුළුවන් අවුලක් නැහැ එහෙම වෙන්නත් පුළුවන් that also can happen but it is a minor product humans can make errors නේ even these molecules can make errors people අවුලක් නැහැ එහෙම වෙන්න පුළුවන් හරිද so minor product එකක් එන්නත් පුළුවන් එහෙම keep that in your mind I won't write it here but a minor product can be formed okay so now what. Now there's the KOH. First of all, the KOH will dissociate. Now KOH is in aqueous solution. KOH will dissociate to form K plus and then OH minus. It will form K plus and then OH minus. Now, there's this molecule CH3, CH, Br. And there's OH minus. And there's OH minus. Now what will happen is, this OH minus will attack, now there is a charge separation, this is plus, this is minus. This is plus, this is minus. So therefore the OH minus will attack the carbon and then remove the Br. And then remove the Br. That's the only thing which you have to do. Easy mechanism. Easy mechanism. It will form CH3, C, H, OH and Br will get removed. So the leaving group, this is the leaving group. And this is the nucleophile. This reaction is a nucleophilic substitution. This reaction is a nucleophilic substitution. And why do you call it unimolecular nucleophilic substitution? That one you should know that it's a unimolecular substitution reaction. To be specific, it's a unimolecular substitution reaction. Why is that? Because when reacting paper, if we write CH3, CH2, Br plus KOH will form CH3, CH2, OH plus KBr. This is the normal reaction if we write in like inorganic format, in physical chemistry format, if we write it's like this. Now people, this is a single step reaction. This is a single step reaction. So that means we can write the rate law for this. R is equal to K times concentration of CH3, CH2, Br. And then KOH. We can write it like this. The order of the reaction is 1 and 1 because the stoichiometry is 1. Right? So this reaction is a bimolecular. Sorry, make a bimolecular, unimolecular, make bimolecular. This is a bimolecular substitution reaction. Make a bimolecular. So this is a bimolecular nucleophilic substitution. How we took it, you saw like this. So this is a elementary reaction because it's a one-step reaction. This is called as an elementary reaction. Since it is an elementary reaction, you can see there are two molecules reacting with each other. So this is a bimolecular nucleophilic substitution. Okay? Bimolecular nucleophilic substitution. That is why we write it as SN2. මේක ලියන්නේ SN2 කියලා. SN2 කියලා ලියන්නේ. හරි? So I don't know where I should keep it. You tell me whether I should scroll down or up or however, just write this down and tell me. No, it's not reversible. It's a strong base. Come on, pharma first thing. KOH is a strong base. It will dissociate fully. You have done pH. Come on. It's a strong base. May pH cover කරපුන් ඉන්නේ class එකේ, right? We have done pH last month. හරි? Okay, can I go to the next one? This is bimolecular nucleophilic substitution. Hari? SN2 type. Next one. Alkyl halide with KOH, secondary and tertiary alcohols. Alkyl halide. Oops. Don't turn on your camera and your mic. Mute. I forgot to remove start video. Hari. Okay, so alkyl halide with secondary, tertiary and a secondary tertiary alkyl halide with KOH. හරිද with KOH. ඕකට NaOH දාන්නත් පුළුවන්. දැන් අහන්න එපා අයියා KOH විතරද පුළුවන්. NaOH බයිද? LiOH බයිද? cesium hydroxide බයිද? Everyone can. හරිද? You just need a alcoholic medium. අර OH minus තියෙන්න ඕන reaction medium එකේ. හරි. Now what will happen is KOH will dissociate. That's the first thing that's going to happen. KOH goes to K plus and then OH minus. KOH and then OH, K plus and OH minus. Then people, the next step of the mechanism only changes. Now the thing is secondary and tertiary carbocations are stable. You know that. Secondary and tertiary carbocations are stable. Therefore, it doesn't need anyone. It will directly dissociate by breaking a bond. By breaking the bond, it will directly dissociate to form CH3, CH3, CH3 plus and then Br minus and then Br minus. And now what will happen is it will get substituted. There you go. Hari? There you go. Here also the reaction is now, now you have an issue. Then make a unimolecular substitution reaction. Calling a bimolecular. This one should be unimolecular. And how is that happening? Now people, in the point of view of kinetics, this first reaction, this is the first step one. This is the step one. And this is the step two. In the step one, people, step one is the rate determining step. Step one is the reaction which will determine the rate. It's the slowest step. Step one is the slowest step. It is the RDS. It's the slowest step and it's the rate determining step. So you can write the rate equation for the rate determining step. So in the rate determining step, you have only this. There you go. And the order is 1 because the stoichiometry is 1. For the rate determining step, for the slowest step, we consider that as an elementary reaction. So therefore, we can write the rate law for that one. We can write the rate law for this. So this is the slowest step. So there you go. So this one is known as a unimolecular nucleophilic substitution. Unimolecular nucleophilic substitution. Right? Unimolecular nucleophilic substitution reaction. So this is like SN1. This is like SN1. Okay? Right. Everyone, I hope you understood it. මීට වඩා ලස්සනට කියලා දෙන්න බෑ people. This is the maximum I can do. I think like only thing I didn't do is I didn't show my face today. Like for 2027 people, I did it while screen sharing. For you people, I didn't do it. Not like I'm shy because I had to like set up everything. This will be like a short session. I think this is not a very long session. That's why. Got it. Okay, can I go to the next one then? Did you write this? Are you still writing or? So let's move on. So after the benzene reaction, then the alkyl halide reaction, let's go for, yeah, aldol synthesis. Let's go for aldol synthesis. Now this reaction, aldol, ketol කියන්නත් පුළුවන්. Aldol. For here, in this particular lesson, I'll take an aldol. I'll take an aldehyde. Aldol synthesis. Okay, the reaction, let me write it. A simplest aldehyde. Reacting with sodium hydroxide aqueous. It can be KOH aqueous also. And what will happen is, දැන් මේක ලියන්නේ කොහොමද? A lot of students doesn't know how to write the product. මං කියන විදිය බලන්නකෝ. First thing I'm going to do is I'm going to extract this part out of this molecule. හරිද? I'm going to extract that part out. Okay, now what? Now I'm going to erase one bond from here. I'm going to erase one bond from here. And then if there is a group attached here, I will write it to the bottom. I'll like මෙහෙම කරලා ලියනවා. I'll write it like this. Okay? Then after that, now there's a group on the left hand side නේ. There's a group on the left hand side. එතකොට ketone එකක් නම් right hand side එකේ තියෙනවා, left hand side එකේ තියෙනවා. However, there should be a vacant hydrogen atom in there. මේ carbon ගේ hydrogen atom එකක් අනිවාර්යෙන් තියෙන්න ඕනේ. There should be a hydrogen atom in that carbon. Now what I'm going to do is, now let me like expand and write this 3 hydrogens. Carbon, hydrogen, hydrogen, hydrogen. This is how I'm like telling you how to write the product. This is not the mechanism. Hari. I'm going to take this hydrogen. I'm going to take that vacant hydrogen and I'm going to give it to the oxygen. Hari. I'm going to give it to the oxygen. So here comes the hydrogen. ඒක දුන්නානේ. ඒක දීලා තියෙන්නේ, right? It has gone now. Now there is no hydrogen there. There is no hydrogen there and there's only a bond. Right. Now people, what you have to do is just attach this molecule to the right of this carbon. Like this. That's going to be the product of the synthesis එකේ y එකත් ඇවිල්ලා. හරි. So this is going to be the product. මෙහෙම තමයි product එක ලියන්නේ. හරිද? This is the product. එතකොට මේකට sodium hydroxide දාලානේ තියෙන්නේ. ඕකේ පොඩ්ඩක් heat කරාම resource book එකේ තියෙන්නේ මේක heat කරාම when you heat this mixture, what will happen is this OH will form a alkene. මේ hydrogen එකත් එක්ක ගිහිල්ලා මෙතන alkene එකක් form වෙනවා. ඒ point එක නෑ mechanism එකේ. mechanism එකේ තියෙන්නේ මෙතෙන්ට නිකන් විතරයි. හරි? ඇත්තටම කිව්වොත් to form an alkene you need to put an acid. acid එකක් දාන්න ඕනේ as the second step of this reaction. නිකන් heat කරා කියලාම alkene එකක් form වෙන්නේ නැහැ ඉතින්. හරිද? ඕකට acid එකක් දාන්න like conc H2SO4 you have to put an acid and then heat it a little bit and then you are going to get the product. හරි. Now let's write the product here. OH hydrogen CH H. Right, this is the product. Hari, this is the product. So what happened is like it will get doubled, right? It will like multiply by 2. Hari, it will get doubled. Okay, so the mechanism mega මෙහෙමයි. Now this is a story, people. This is a story. There is the aldehyde. There is the aldehyde. Let me draw it like expanded way. I'm going to expand කරලා ලියන්න. Carbon, hydrogen, hydrogen, hydrogen. Hari. You know, oxygen is the second most electronegative atom in this whole world, and carbon cannot even turn with it. What's going to happen is the oxygen will attract electrons from the carbon. It will attract electrons from the carbon, so oxygen will get a positive charge. Carbon will get a negative charge. Now carbon doesn't have electrons. Carbon will take from the other carbon. එහා පැත්තේ ඉන්න carbon ගෙන් ගන්නවා. මෙයා minus, sorry. මෙයා minus, මෙයා plus. The oxygen will get electrons and the carbon will get positive. And then the neighboring carbon, the carbon can't take from this hydrogen. පව් කියලා හිතනවා නිකන්. හරි නෑනේ ඉතින් like. So the carbon will be like, it will ask from the neighboring carbon. So neighboring carbon, it will withdraw electrons, and then what will happen is that carbon will get negatively charged. හරි. That carbon will be like, එයාත් negative නේ දැන්. එයාටත් electrons මේ පොඩි අවුලක් තියෙනවා එතන. හරිද? උගෙන් electron ගත්ත එක ඌ මේවා කරනවා මේ hydrogen ගෙන්. හරි? He's going to take the hydrogen's electrons. Now what will happen is hydrogen is the person who is like suffering at the end. Now what will happen is the OH is there. The OH. First of all, the OH dissociation I didn't write. I had to write that also. Sodium hydroxide, it will dissociate to form Na plus and then OH minus. It will form OH minus. And then OH minus in the solution, we'll look at this incident. We'll look at this incident and help this hydrogen. Hydrogen is feeling very bad right now because like it's like, look at you. Electrons stick ගන්නවනේ, like every day hydrogen's electrons only everyone is taking. Then make it බලන්න the above mechanism. Above mechanism කියන්නේ මෙන්න මේකේ මේ hydrogen ගේ electron අරගෙන. පවු නැද්ද කියන්නේ like every mechanism we talked about, like 80% of those mechanisms, hydrogen is the one like everyone is taking electrons from. I don't know why is that. However, like he should go to like මේ මොකද්ද මේ මානව හිමිකම් එකක් තියෙන්නේ මේ මුන් මානව නෙමෙයිනේ මුන් ඇටම් හිමිකම් එකට ගිහිල්ලා මේ he should like probably put a something like එහෙම මොකක් හරි කරන්න වෙනවා නැත්නම් හරියන්නේ නැහැ වැඩේ. හරි, like every day hydrogen's electrons only everyone is taking. It's like the person who is getting bullied in the class. Every day he is getting bullied. Human rights නේ මට ඒ ඉංග්‍රීසි වචනේ මතක් වුණේ නැහැ එකපාරට. Human rights. So he should go to the atom rights. Right? Atom rights එකට ගිහිල්ලා he should put a what do you call මොකද්ද බං එකට කියන්නේ මන් දන්නේ නැහැ. හරිද? So there is the OH minus, and then what will happen is it will attack the hydrogen. හරි? It will attack the hydrogen. Now what will happen is hydrogen will be like, okay, I don't want to electrons. I complained it to the atom rights, and then they have gave me a solution. Yes, complain. They have gave me a solution. Now I'm going with OH minus. You keep your electrons. I don't want it anymore. Hari. Patta ulak දැන් වෙලා තියෙන්නේ. දැන් මොකද වෙන්නේ? Carbon is alone now. අර emoji එක තියෙන්නේ එහෙම එකක්. එහෙම කරගෙන ඉන්නවලු දැන්. හරිද? carbon එහෙම ඉන්නවලු. අයියෝ carbon ඉන්නේ එහෙම ආතල් එකේ නෙමෙයි. he's like very sad now, like the hydrogen is gone. ඔහොම ඉන්නවා. H2O is getting released now. අර OH minus hydrogen එක ගිහිල්ලා දැන්. හරිද? water වෙලා ගිහිල්ලා දැන් ආයෙ හොයන්නත් නැහැ. හරිද? Now this molecule, this is the second step of the mechanism. This molecule is there. ඒ මොලිකියුල් එක නෙමෙයි, this original molecule. ඒ කියන්නේ මේ original molecule එකම ආයේ මෙතන අඳින්න ඕනේ. හරිද? Now the same thing will happen to the another molecule. Another molecule also will undergo the same fate. But do not forget that we can change the fate. හරිද? You can change your fate. Even the molecules can change their fate. How do you change your fate? So if there's an ayya or akka who like messed up their A levels, because of something which they did in their life, because of something they might have missed their A levels, and then probably they might have got 1F, 2F, 3F or මාකරයක් එන්න බලුවා. So you ask them why did they got it. ගුටි කන්න මේ කැමති නම් විතරක් කන්න. Some people don't like asking like that. මේ ගහනවා අනිත් පැත්තට එකක් මේ හරිද? ඒකට මේ අහන්න පුළුවන් එක්කෙනෙක්ගෙන් අහන්න, right? So someone like, why did you get a result like this? හරිද? So ask them and they might tell you the reason නේ. So something like that will happen here also. Now this molecule is like messed up totally. This molecule is messed up totally because of this incident. And he will not let another molecule go the same thing. ඒ කියන්නේ මෙයාටත් ඒක වෙනවට කැමති නෑ. That is the real humanity. Humanity නෙමෙයි atomanity. හරිද? atomanity කියලා කියන්න humanity atomanity. That's the real atomanity. Okay, now auto correction is a problem now. This is the real atomanity, right? Yes. Hari. Now what will happen is this molecule will come and look at this incident. Bro, don't do that. Don't do that thing. Oxygen, please don't do that. Oxygen, may carbon again. Carbon, please don't take the electrons of your neighboring carbon. He will undergo a very yes. He will undergo a very big issue. Please don't do that. I can help you. I can help you get your electrons. I can help you get your electrons. Please don't do that. I can help you. I will give you my electrons. I will give you my electrons. You don't take the electrons of the other carbon. And then what will happen is a reaction will take place and it will form it will go for a reaction like this. Hurry. Now what will happen is as the next step of the reaction, now make a water reaction එක නිකම් මෙහෙම ලියන්න බලන්න කිසි අවුලක් නැහැ. H2O. අර මෙතනින් ගියේ H2O වෙන්නත් පුළුවන්. ඒකම නෙමෙයි වෙන මොලිකියුල් එකක් වෙන්නත් පුළුවන්. එයාම එන්නත් පුළුවන්. හරිද? ඒකල ඒ හයිඩ්‍රජන් එකේ ඉන්නේ. ඒ හයිඩ්‍රජන් එක ඇවිල්ලා මෙයාට ඇටච් වෙනවා. CH3 C OH CH2 C double bond oxygen hydrogen. හරි. සුපිරියට තේරුණානේ. අවුලක් නැහැනේ. හරිද? මෙකැනිසම් එක ඔච්චර තමයි. අර කටපාඩම් කරලා මේක 100 පාරක් විතර ඇඳලා ඕන්නේ නැහැ people just study it like a story. You can create your own story. හරිද? Just create your own story. හරි. ලියලා ඉවරද people you can tell me when you're done. So we will may here OH minus acts as a catalyst. Okay, then මෙතන OH minus release වෙනවා. OH minus will act as a catalyst. OH minus will act as a catalyst. Hari, type of the reaction, yes. Scroll up a little. Okay. The type of the reaction is nucleophilic addition, but it is commonly told as a condensation reaction. Commonly told as a condensation reaction. This is a nucleophilic addition reaction, but it's like commonly told as a condensation reaction. Here, people, the nucleophile is this iron. This one. මෙයා තමයි මෙතන ඇඩ් වෙන්නේ. මෙයා තමයි nucleophile එක. හරි. Then next one. HCN, hydrogen cyanide with aldehydes and ketones. HCN with aldehyde and ketone. HCN with aldehyde and ketone. Right. So let me draw a compound. Acetone, okay? Because it was given in 2024 A levels. Acetone molecule, they just gave the name, they didn't give the molecule. However, be careful. Benzyl dehyde වගේ එකක් දුන්නාම දන්නේ නැහැ සමහරව මොකද්ද මේ කියන්නේ කියලා. හරි. Acetone කියලා දුන්නේ. They gave the word acetone. Write the mechanism in between acetone and HCN. That is what they gave actually. මේ සමහර කට්ටිය දන්නේ නැහැ ඉතින්. Acetone කියන්නේ මේකට. This is acetone. Hari, this is acetone. So what will happen is the acetone or aldehyde both can react. It will react with HCN. It will react with HCN to form a compound like this. Hari, a compound like this. So the mechanism of this reaction, interesting. First of all, HCN will dissociate. HCN will dissociate to form H plus and then Cn minus. To form H plus and then Cn minus. Then after that, the molecule, the acetone is there. The acetone is there. Negative, positive charge differentiation. Then there's the Cn minus. Will attack this carbon. Attack the carbon and the bond will get removed. Minus CH3 Cn. This is the nucleophile. This is nucleophilic addition. Nucleophilic addition, and this is the nucleophile. And then the remaining H plus, who is like roaming around, he will also get attacked by this oxygen, which will form an OH. This will form an OH and a CN group. Okay, let's scroll up a bit. Did you tell that now or before? Megani? Ah, yes, Sachini. HCN dissociation reversible. Like a Ganak again, KCN තමයි dissociate වෙන්නේ fully. HCN is like dissociating reversibly, but that point is not checked much. Then the maker not necessary. In the resource book, we don't have this reaction. Then next on HCN with aldehyde and ketone done. And then next one we had to discuss about aldehydes and ketones. Aldehydes and ketones with Grignard reagent. With Grignard reagent. Right. Now the thing is Grignard reagent කියන්නේ මෙන්න මෙහෙම එකක්. There is a bond in between the carbon and the magnesium atom. හරිද? X කියන්නේ මං chlorine හරි bromine හරි whatever it is. හරි? And there's a charge separation in between them. Now magnesium is getting a delta plus and he's getting a delta minus charge. හරිද? Right. So this guy can act as a nucleophile. This person can act as a nucleophile. එතකොට මේ reaction එකේ කවුද nucleophile එක හුවොත් එහෙම the Grignard reagent itself is the nucleophile. Right? So let's write the reaction aldehyde or ketone. Let's draw acetone. Let's take acetone for example. And then there is CH3 MgX. Okay. Now what will happen is this will attack the carbon. Here charge separation occurs. Charge separation occurs and it will attack the carbon. And the bond gets removed, which will form CH3CO minus CH3 CH3. Now what will happen is MgX එක තියෙන්නේ. ඔය MgX එක ගිහිලා මේ oxygen එකට attach වෙනවා. It will attach to the oxygen molecule. හරි? It will attach to the oxygen molecule. හරි? This is called as an දැන් මේක methyl group එකකට attach වෙලා තියෙන්නේ. හරිද? ඒතර මේකට කියනවා methoxy magnesium bromide. එතන methoxy magnesium halide X එකන්නේ මම දාලා තියෙන්නේ. හරි නම ලියන්න ඕනේ නැහැ. හරිද? නමක් ඕනේ නැහැ. Just keep it like that. මේක methoxy magnesium halide. මෙතන bromine එකක් තිබිලා මෙතන R group එකක් දැම්මොත් alkoxy magnesium bromide. Hari. Now what will happen is this one will undergo hydrolysis with water. Hydrolysis with water, H2OH plus, and then it will form CH3, COH, CH3. So this is the step number 2. Hari, make one step number 2 hinda wenama liyananne. Since this is the step number 2. So the overall reaction, we can write it like this. Okay, then එතකොට මේක මොකද්ද? This is a nucleophilic addition reaction. This is a nucleophilic addition reaction, and the nucleophile is the Grignard reagent. Nucleophile is the Grignard reagent. And then after that, alcohol. Let's go for alcohols. Alcohol with HBr. Alcohol with HBr. Okay, so it will form CH3, CH2OH. So CH3, CH2OH will react with HBr to form Br. හරිද? හරි. දැන් මේ රියැක්ෂන් එක කොහොමද වෙන්නේ? මොලිකියුල් එක තියෙනවා. And there's the HBr molecule also. And there's charge separation that occurs. The oxygen will look at the hydrogen. The oxygen will look at the hydrogen and it will attack the hydrogen, causes it to remove the bond. Causes it to remove the bond, and it will form a molecule like this. The Br who looks at this, now things are, cation people, this is very ugly. What will happen is the Br will attack this carbon now. It will attack this carbon now and will cause to remove this bond. And then it will form CH3, CH2Br, and then water. This is nucleophilic substitution. Nucleophilic substitution. Here the nucleophile is Br minus, and the leaving group is H2O. එතකොට මේ රියක්ෂන් එක වෙන්නේ only with HBr and HI. හරිද? With HCl people there you need a Lewis acid. හරිද? You need a Lewis acid. ඒක මම ඊළඟට කරන්නම්. අර you need zinc chloride. ඒකට mechanism එකක් we don't discuss, but we need what do you call මේ a Lewis acid in order to make that reaction happen. This won't work for HCl, okay? This won't work for HCl. Does not work for HCl without Lewis acid. හරිද? For HCl you need to put zinc chloride. ඕකට අපි කියනවා Lucas reagent එක කියලා. Lucas reagent එක දාන්න ඕනේ reaction එක වෙන්න. Then people next one මේ වගේම එකක් තියෙනවා alcohols with PCl3 වගේ කට්ටිය. හරිද? alcohols with PCl3 වගේ කට්ටිය. මේකේ mechanism එක අපි ඉගෙන ගන්න. We are not learning the mechanism. So if you write the reaction ROH will react with PCl3 නැත්තම් PCl5 ගන්නත් පුළුවන්. දෙකම ගන්න පුළුවන්. PCl3 ගන්න පුළුවන්. It will form RCl plus POCl and HCl. මේ reaction එක nucleophilic substitution and the nucleophile is the halide ion නැත්නම් Cl minus කියලා ගන්න පුළුවන්. හරි. sorry people මේක PCl5 කියලා දාගන්න. PCl5 එක්ක තමයි මේ reaction එක කරන්නේ. PCl3 එක්ක වෙනම reaction එකක් තියෙන්නේ. මේක special point එකක්. This is an A+ point people. This is an A+ point. හරි. Alcohols with PCl5 this reaction it will form these products. POCl3 and HCl. හරිද? It will form POCl3 and HCl. Wait. It will form POCl3 and HCl. This is a nucleophilic substitution reaction and the nucleophile is Cl minus. Alcohols with PCl3 and others, alcohols with PCl3 or PBr3, these reactions people make a product එක වෙනස්. ROH product එක වෙනස් කියන්නේ මෙහෙමයි. PCl3 it will form RCl plus H3PO3. මෙන්න මේ ප්‍රොඩක්ට් එක තමයි ෆෝම් වෙන්නේ. ඒක ස්පෙෂල් පොයින්ට් එකක්. ඔක දන්නේ නැහැ ගොඩක් කට්ටිය. මේ මටත් මෙතන අමතක වුණා ඒ පොයින්ට් එක. Now only I remembered it. ROH with PBr3 it will form RBr plus H3PO3. හරි. මේ පොයින්ට් එකත් මතක තියාගන්න. This is like an A+ point. මේක අහන්න තියෙන chance එක ගොඩක් අඩුයි. There's a very less chance of asking this but can be asked. So the product is what differs. Hari, product is what differs. This POCl3 here and H3PO3 here. මෙතන HCl එකක් මේ වෙනම යන්නේ නැහැ. ඒක තමයි වෙනස. Where do you need me to scroll now? Here? Up here? This part? Okay. එතකොට මේකේ නියුක්ලියර් ෆයිල් එක මේ halide ion එක හරියද ඉස්සෙල්ලා ලියපු එකේ? Yes, it is same as PCl5. Both are same. හරි මේකම තමයි මෙතෙන්ටත් එන්නේ. The same thing. Yes, PBr3, Br minus. What I told is like the halide. හරි PBr3, Br minus. PBr3 වල Cl minus එන්නේ නැහැ anything. You can understand, right? Okay then. Let's move on. එතකොට මේ alcohols formation of alkenes or alcohols වලින් alkyls form වෙන්නේ මේ conc H2SO4 ඒ වගේ reactions elimination reactions. I'll write that one only. Alcohol නෙමෙයි alcohol to form alkenes. This reaction conc H2SO4 conc H2SO4 and heating, this reaction will produce CH2. This reaction is an elimination reaction. You can use may Al2O3 also, Al2O3 and heat. This one also you can use. When you look at chemistry in a student's point of view, people, it's different. Like in a student's point of view, the things you see are different. In a teacher's point of view, the things you see are different. The way you look at the syllabus, it's very simple. When you look as a teacher, the syllabus is simple. When you look like a student only, it feels very complex. These PH and all everything like very complex. But when you look it after you finish A levels, just try to teach to someone you will feel like this is nothing. Like A level, like chemistry is nothing. And after finishing A levels and like getting an A for chemistry, and then after that you try to teach it to someone, you will feel like this is not complicated as we thought it was at the beginning. So you're just in a matrix. You just think like this is the hardest thing on earth, but it's not actually. It's like you look at O levels right now and you think like, what was that? Right? You're like, what is that in O level science book? Like we know beyond that, right? Something like that. During O levels, we thought like O levels is the hardest thing. We have to study 9 subjects. 9 subjects we had to study, and then like I hated like some subjects I hated. Oh my God, like literature and all I did because I couldn't do anything else. Literature I did because I didn't like, I mean, like I didn't feel like to do music and like I didn't feel like to do arts and all. My arts are like, I don't know, can't even explain. People can't look at it. May so that's why I did literature, and literature I hated. I hated aesthetic subjects. Yes. O level is nothing. O level science, maths, and everything, like maths and all, like it was nothing compared to what we learn right now. I didn't think, bro. Okay, let's go for the next reaction. Amine with aldehyde and ketone. This is 16th one. 16th one කියන්නේ මගේ book එකේ 16. ඔය කට්ටිය කීයද දන්නේ නැහැ. මගේ note එකේ. කියන්නේ මම ඒ කාලේ ලියපු note එකේ 16th one. ඔය කට්ටිය කොහොමද දන්නේ? I'll write just amine with ammonia or amine. Both you can write with aldehyde and ketone. Ammonia and amine with aldehyde ketone. So here, when you react it with an amine, RNH2, or you can react with ammonia also, just pretend that the R is a hydrogen. You will get an imine. This won't work for me. This one, huh? It won't work for this. It won't work for secondary amines. It won't work for tertiary amines also. It will only work for primary amines and ammonia. Huh? It doesn't work for other amines. Keep that in your mind. What the hell is that? Okay, nice. This will form an imine. How is it formed, people? I'll tell you how is it formed. Nitrogen and R and then CH3. So what will happen is this CH3 group will give its oxygen like this. And the R group will give its hydrogen like this. And then what will happen is a water molecule is getting removed. Water molecule is getting removed, which will give you this product. Which will give you that product. That's how it is formed. Now look, people, if there was 2 R groups and 1 hydrogen, you can't form water, right? So that won't happen. Okay, then let's write the mechanism. CH3, C, double bond oxygen, CH3. So now there's a charge separation, delta negative, delta positive. Now what will happen is the R group is there and the nitrogen and the 2 hydrogens. Now what will happen is the nitrogen has an electron pair and it will attack this carbon and the bond will get removed. And then there's a weird thing happening here. The oxygen will take revenge. Now, amine molecule attack the ketone. It will attack the ketone. So this oxygen will be like, okay, I will also attack you. It will re-attack this molecule and take its hydrogen away. It will take its hydrogen because it's like now oxygen has a negative charge and it doesn't like it. This nitrogen also has a positive charge. It doesn't like it. So what will happen is this hydrogen will be given to the oxygen, which will form this molecule, CH3, C, OH, CH3, and H R. Now you know, like, this is not the molecule you told me. Then how can we, like, what's happening here? Now a water molecule is getting removed from this molecule. It's not added or anything, it's getting removed. ඒ කියන්නේ මේක. හරිද? This OH and this hydrogen will get removed as water. This OH and this hydrogen will get removed as water, and a double bond will form in between this carbon and nitrogen. That's what will happen. Then minus H2O කියලා ලියන්න. In the exam, in the mechanism, if they ask, write minus H2O. Then you can get CH3 double bond nitrogen R. There you go. So write this down. එතකොට මේකේ type එක වෙනස්. This is nucleophilic addition followed by elimination. That is how you should write in the exam. Nucleophilic addition followed by elimination. Nucleophilic addition followed by elimination. So the reaction with 2,4-DNP is also the same. හරිද? 2,4-DNP එක්ක යන reaction එකත් මේ වගේම තමයි. Okay, can I move on now? Okay, now primary amines. Amines reacts with what do you call? මොකක්ද මේ acid chloride. This one, the number is different, so I'll write acid chloride with ammonia. Acid chloride with ammonia. Right. Acid chloride with ammonia, let's write. Now the product will be CH3C double bond oxygen chlorine. You react it with ammonia, you heat it a little bit, and then you get an amide, right? You get an amide when you react with ammonia, right? The mechanism looks something like this. Just like the previous one, attack, and then to form a compound like this. And now only the interesting part happens. The oxygen will give its negative charge and the electrons to this bond. And what will happen is this chlorine will get removed. The chlorine will get removed and the chlorine will go and attack one of these hydrogen. That's the funny part. It will attack the carbon with the bond and it will form a bond with carbon, sorry. And then what will happen is like the chlorine will get removed and chlorine then doesn't go just නිකන් යන්නේ නැහැ. අර වෙන එකේ කැරම්ම තමයි යන්නේ. හරිද? It will go with another hydrogen. It will attack one of the hydrogen and remove a bond. And then you get this product. So nucleophilic addition followed by elimination. Nucleophilic addition followed by elimination. Nucleophile is ammonia. Nucleophilic addition followed by elimination. Okay then. First step here. Okay, let's move on. Next one. Acid chloride with ammonia done. And did we do acid halide with alcoholic base? Alcoholic base reaction we didn't do. Acid alkyl halide with aqueous base only we did. So right there, alkyl halide with alcoholic base. Acid halide with, alkyl halide with alcoholic base. So here CH3, CH2, Cl will react with KOH, alcoholic, to form the alkene CH2, CH2, CH2. Right. The reaction we can write, the mechanism we can write. So KOH will dissociate first. Let me write that. And the charge separation occurs. So this is delta minus, delta plus, delta minus, delta plus. Now what's going to happen? The OH will attack the hydrogen. Hydrogen will give the bond to here. And then this bond will get removed. And it will form H2O. It will form H2O and then Cl minus. So this reaction is an elimination reaction. This reaction can also happen with the OCH3 group. නිකන් මෙහෙම එකක් වෙන්නත් පුළුවන්. It can happen with the OCH3 group also. හරි? Something like this. හරි. Then the next one. Then the next one. So this is the alkyl halide with alcoholic base and acid chloride with alcoholic base. Next one. Acid chloride. තව පොඩ්ඩයි තියෙන්නේ. Another two more, I guess. Acid chloride with alcoholic නෙමෙයි with base. Right. So here the reacting compound CH3 C double bond oxygen Cl. Sodium hydroxide will first dissociate. Let me write that. Sodium plus and then OH minus. Here charge separation occurs, delta plus, delta minus. Yeah, and OH minus. He will attack this carbon. He will attack this carbon, which will cause the removal of this bond. So nucleophilic addition. And the nucleophile is OH minus. And then you know what will happen. It is followed by elimination. This is followed by elimination. So this is nucleophilic addition followed by elimination. Nucleophilic addition followed by elimination. There you go. Write this down. So this is acid chloride with base. We have done like probably මගේ count එක යනවා around 20 වගේ. I don't know whether you have numbered it from the beginning. Right, so next. What was that? Who typed a GF there? Come on, I didn't type that. Can't I delete this whole thing? No? Oh my god, what is happening? Okay, whatever, just ignore that. Right now, esterification, ester formation, a reaction එකත් ලියමුකෝ එහෙනම්. I think that's the last one. 13th one නෙමෙයි මේ 21st one. Ester formation. Ester formation, there is the carboxylic group with the OH, and there's the alcohol group CH3OH. Hari? CH3OH. And the charge separation occurs delta plus, delta minus. The oxygen will attack the carbon, removing this bond. It will form this unstable compound. Now what will happen is this oxygen will attack the hydrogen and remove the water, remove the hydrogen of it. This is not elimination, people. Nucleophilic addition, okay? And the molecule is rearranged, actually. Oops. Elimination එකක් වෙනවා මෙතන. Some elimination is happening here. මෙතන minus H2O. Minus H2O, yeah. Elimination happens. Nucleophilic addition followed by elimination then. Water molecule is getting removed. Actually, this water molecule is getting removed out. Hari. And it will form this ester. It will form this ester. There you go. All the mechanisms in the syllabus I completed in these 2 videos, and there is one mechanism I'll give in case you will see this in term test papers and provincial papers, I guess so. Lithium aluminum hydride reaction, reduction using lithium aluminum hydride dry ether of an aldehyde or a ketone. So just in case, this mechanism, just write it. So let's say an aldehyde is there. An aldehyde is there. And there's lithium aluminum hydride. This will dissociate, forming lithium plus and then aluminum hydride, AlH3, and then H minus. It will form this compound. So what will happen is H minus will attack this carbon. H minus will attack this carbon. So there's a charge separation. H minus will attack this carbon. And then what's going to happen is there is water. There's water here. There's water here. It will form H OH නේ මෙහෙම එකක් නේ තියෙන්නේ. delta minus delta plus නේ. හරිද? මෙතන තියෙන හයිඩ්‍රජන් එක ගිහිල්ලා මේ ඔක්සිජන් එකට attack කරනවා. You don't need to know details of this mechanism, but it's a weird one. හරිද? මෙහෙම ගිහිල්ලා උඩින් ගහනවා. And the product that is formed, interesting, this hydrogen, හරි? This hydrogen will move to here, okay? I'll put it in red color. CH3CO and the hydrogen here, red color. Right? Hydrogen there, red color, and this hydrogen here will move to the bottom. I'll put it in yellow color, this one. So this hydrogen, yellow color. Hari? The other hydrogen will come here. Now, what's the important part here? In case if they gave, there is a MCQ like this. I have seen this MCQ in some, I don't know, Mora paper somewhere. I did it in last year. They gave lithium aluminum hydride and D2O, not H2O. They asked the product. Right? They asked like they changed this hydrogen, they changed this hydrogen, they changed this hydrogen, and they gave several answers. The correct answer is now if this is D2O, then this is D and this is D. And then this D will go and attack this hydrogen, so it will become D here. It's like OD. In case if you see that MCQ, so just know that. Okay then. You can leave the meeting. We have completed everything then. Everything that is needed to be completed is completed right now. The mechanisms done. Okay. All the mechanisms are done. All the mechanisms are done. So organic, not fully revised. Actually, the mechanisms, everything we revised. Right? So this is a free session. Like I didn't take money from other people. Like this is an organic group class. Of course, this is an organic group class, and this is a session for them. Actually, I decided to put this for everyone because everyone is suffering with mechanisms right now, and nobody's there to teach these lithium aluminum hydride things. There's no one to teach these things. So here you go. Everything is there for you. 2 videos and mechanisms are completed. So please drop me your comments regarding the class if you can, and if you have a small time. Just don't type long paragraphs. Just put a small message to me, like how was the class, did you understand, and those things. Is this effective? Like more than doing in front of a whiteboard, is this good, or like is that good? And like drop your ideas to me in private. You know my WhatsApp number. You can put a message to there, right? So thank you for joining. Hope you enjoyed the session. Organic students who are there in the group class, now you guys, next we have to do acidity variation, basicity variation, and then it's over. Then boiling point variation, and then organic is complete. Isomerism part is also complete. You can leave the meeting now. Thank you for joining.